Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about the last law, which is the power of powers. So as I always say, try as much as possible to review the previous video, and especially law 4, because this is just a step further from law 4, all right? So the power of powers talks about when you have an index like this, so x raised to the power y and y is raised to the power z. Okay, so for example, you have something like 3 raised to the power 2, and 2 is now raised to the power 2 or something. All right, so how do you solve this? All right, so there are 3 rules for this. So the first thing you have to do, you have to solve the power first. Okay, you solve the powers first. Then number 2, after solving the powers, then you now apply the resultant to the base. Okay, the resultant to the base. Okay, so the resultant you got from step 1, you apply it to the base. Then after you've done that, you what? You simplify. So that means if you have something like x raised to the power y and y raised to the power z, what you do first, you first solve y raised to the power z first, you get an answer, then you now apply it to the x. Is that okay? So that's what you do. So let's pick some example here, all right? So let's say I have, for example, let's start with this one, the one we already have on the screen. 3 raised to the power 2 and 2 raised to the power 2. So what are we going to do first? It's going to be 3 raised to the power, we'll solve the first one, 2 raised to the power 2, and that will give us what? 4. Then we now solve 3 raised to the power 4, and that will give us what? 81, okay? Let's pick another one. Let's assume we have maybe 2 raised to the power 3 and 3 raised to the power 4. Then it should now give you 2 raised to the power 3 raised to the power 4 is 81. Then if you same thing as about 2.418 times 10 to about 24. So if you want to put it in standard form, it will give you something about this, okay? And also, you can also guess in some cases where you have more than one thing as well, where you have to combine more than one rule. Let's assume we have 3 raised to the power 2 and 2 raised to the power 5 is equal to 81 raised to the power 2x plus 2, okay? We can solve this. It's going to give us 3 raised to the power, 2 raised to the power 5 is 32. It's equal to 81 raised to the power 2x plus 2. Now, when you see something like this, what should come to your mind should be law 11, equality law. All right, so then we'll start solving it, having equality law in our mind. So 3 raised to the power 32 is going to be 81 is 3 raised to the power 4, 2x plus 2. So 3 raised to the power 32 will be equal to 3 raised to the power 8x plus 8. I remember I told you a raised to the power m is equal to a raised to the power n. Therefore, m must be equal to n. Equality law, right? That's law 11. So now, for this to be equal then, so 32 must be equal to 8x plus 8. You take 8 to the other side, so it's going to be 32 minus 8 is equal to 8x, all right? Then 32 minus 8 will give us 24 is equal to 8x. So therefore, 8x is equal to 24. Now to get x, you divide both sides by 8. So therefore, x is equal to what? 3. And that is that for that. And yes, so that's the powers of powers. All right. So the first thing you do, you solve the powers first. Then you now apply it to the base. Is that okay? After which you now simplify based on the question. All right, that is the 12 laws. Okay, that's law 12. Okay, so you can go to the textbook. Other ones you might get other laws, but these are the most popular 12 laws. That other laws are more of like manipulation of these laws as well. All right. So if you have any question, please feel free to let me know. Drop it in the comment section, or you can also send me an email directly, and I will get back to you. So I'm going to see you in the next video. So the next video, we'll talk about how to simplify indices. So we're going to solve some questions now. I'm going to play around with some indices questions. So I'm going to see you in the next video. All right. So see you soon.